I wanted to welcome everyone here. We don't often share our webcams during these sessions, but since many of you have seen me on our YouTube channel, I thought I'd say hi. And I am going to be talking about relational to graph here, and we said most were developers, right? With a developer audience in mind, I will cover some use cases and other things about Neo4j for those of you that are brand new to Neo4j. Then I will cover the developer-friendly material as well. And so if you have any questions, ask them through the chat. We'll be taking questions at the end. And I think that's really about it. I just want to say that this is one of the more common topics related to Neo4j, as people are moving from relational databases to a graph database, or using the two in kind of a polyglot architecture. And that's fairly common. Neo4j was actually, when it was first built, the founders were at another company doing a content management system, and they ran into the join bond problem with their relational database at the time. And that's how they created Neo4j. So they first found it difficult to run graph-like queries in SQL, writing those queries. They built a graph layer on top of their SQL database, but then found it wasn't performant enough for the graph queries. And that's how Neo4j was born. So many of you are probably in the same position. And we're going to get into it here. So let me turn off my webcam here, and I'll switch over to the presentation. But welcome all, and hope you enjoy the webinar. All right. So relational to graph. Well, first I want to kind of talk about the origins of databases. And data used to be stored like this, punch tape or punch cards. And really it's a horrible way to read and understand data, but it was the best technology available at the time. And then came along the idea of storing data in tables, in columns, in rows. And that was a great way to store and represent your data as long as it was tabular. And then when you started to join multiple different tables together, you ended up having these not so readable tables of a bunch of foreign key references. But it still was a decent way to represent data. And in particular, you had ACID compliance with your data, and the ACID compliance was very important in order to ensure your reliability of your data that you're using with Neo4j. Now, this traditional data structure has been used across a wide variety of different organizations within companies. So whether it be HR tools or support tools, payments, logistics, CRM, all sorts of different use cases, this traditional data structure has been used. Now, as you get sort of to the modern world and people are doing more and more things online, we're shifting towards these systems of engagement where we want to understand how all of these different data sources interlink. So we have users engaging with multiple devices, and users engaging with different users, and devices in the IoT world engaging with other devices. So a lot of ways that this data needs to interact with each other and not just be stored in these silos in tables. So in general, systems of record, when you have a relational database model, were structured, pre-computed, based on fairly rigid schemas or rules. In this world of systems of engagement, the NoSQL flexible database models tend to be a better way to represent this data, and you want to have real-time queries and be contextual. So as we shift here, we shift from the table to a graph-like structure about how all of this data interrelates. So Neo4j was created for these three primary purposes: intuitiveness, speed, and agility. So intuitiveness is basically the ability to read and understand your data, the ability to write queries that represents what your data looks like, rather than just typing in random syntax in order to get the results that you want. And so that's very important for us, and it's very important for most business people and developers as they onboard new people onto their team, that they're able to quickly and easily understand the data. So we like to say that the whiteboard model is the physical model. What you would draw up on the whiteboard as a business person or as a developer is the way that we represent the data in the underlying database. And the way that the data is queried, stored on disk, etc. It's all the same thing. There's no translation between each of these layers, and having no translation between the business and the developer and between the developer and the underlying structure really allows you to better understand and work with your data and have it all really just make sense. That speeds up the development process, which is the next point here. So speed is about two things. Speed is about the speed that I just talked about, the intuitiveness creating speed in your development process, as well as the speed of actually querying your data. So every database, of course, has its trade-offs. Different data models have their trade-offs, but Neo4j is really about high-performant queries of transactional data. So this means that as you query your data, basically your data size can grow and the query time can actually remain constant as long as you're still querying the same amount of the data within the database. And we'll see how that works here shortly. But this is actually the reason that a lot of companies had adopted Neo4j, I would say, in the first 5 years or so that Neo4j existed. This was the primary reason people came to Neo4j, was to get the performance that they needed to build real-time applications on top of a transactional database. And we have the train outside, where we sit in the Silicon Valley or in the peninsula right along the train line. So excuse that train. But anyway, so we have speed, not represented by our trains. Our trains are not very fast, but and this is a quote from eBay, Volker at eBay. We found Neo4j to be literally thousands of times faster than their previous MySQL solution, with queries that require 10 to 100 times less code. Today, Neo4j provides eBay with functionality that was previously impossible. And so, this is actually really what we're trying to deliver for both developers as well as businesses. Make it a lot easier to write the code. You have to write a lot less code. Make it a lot faster for you to execute your queries and provide a service for your customers. And thus, it makes new types of applications possible. And speed, I mentioned, as you're able to have a constant performance even as your data size grows, as long as you're going on the same size of data. And that's really because of the native graph database technology. We're built from the bottom up as a graph database. What our developers internally at Neo4j deal with every day is graphs. We are focused on graphs as our primary data model. And this is really important to us because we believe that graphs are unique in some ways from an implementation standpoint, and having that expertise to work with graphs day in, day out certainly helps us make a much more optimized database. So what does native mean in the underlying data? Well, some data could be considered natively as tables. And if you look at data like this, we have an employee records, and these are all represented as tables. Some data could be natively stored in sort of a key value format. You send a key, you look up a value, And this, was some of the popular NoSQL databases. Some data could be represented as documents best, and some databases support documents best. This is really an important point here, that every database is choosing its sort of native format. They may add layers or query languages on top to query the data as graphs, but they still have a native format. You're either natively tabular, or you're natively key value store, or you're natively a document database. And that's really how you store your data on disk, in memory, and what your developers care the most about. It's usually the origins of the database. So this matters a lot, because that's really what you're optimizing for. And if you can think of a traditional relational database query, you might have 3 separate tables, like something like this, for the employees at the top left, their managers, so basically what their reporting relationship was, which they can have multiple different reporting relationships during their tenure at an organization, and that's in the top right here. And then the bottom, where their office was located at. I previously worked for Google, and I think I had like 17 different offices in my 8 years there. So people can switch around a lot. And so your traditional relational database query looks something like this. And if you think about how you actually run your queries, what you are doing is looking at the primary keys of the data, and potentially, foreign key references as well. And you're doing index lookups on these things as you do your join queries. So you write a join query that joins across these 3 tables. In this case, you're doing 16 plus different index lookups in order to query this data, and that's super expensive. Alternatively, from a graph database perspective, or a native graph database perspective, this is the property graph model. You're seeing what are nodes, or the nouns in the model. You're seeing the verbs, which are the relationships in the model. And you would do a single index lookup to find your employee nodes, or to find a particular employee. But then as you traverse the graph, as you follow the relationships from one employee to their office to the building, you are not doing additional index lookups. We call this index-free adjacency, because what it means is you're really doing pointer arithmetic in memory to get from an employee to an office to a building. And as you computer scientists know, pointer arithmetic is a really cheap operation. Much cheaper than doing many, many index lookups. And this is really what gives Neo4j as a native graph database the performance advantages that you're looking for. Agility is the last step here, and agility is about the schema optional nature of Neo4j. You can add and remove properties in Neo4j on the fly. You can add and remove relationships on the fly, and you can add and remove nodes on the fly. And this is what's really important for a lot of people using our applications, using our database with their applications, is their applications are changing regularly. Their applications have new requirements on a daily basis. It's no longer the case that we maintain, most of the same application code for 20 years. People are expected to have weekly or monthly, or maybe at times quarterly releases, but you're expected to keep those applications up to date with the latest business requirements. So you need your database to support that. You don't want to have to be doing a bunch of schema migrations, but at the same time, you do want to have some ability to enforce the schema through your indexes and constraints. And Neo4j does have some constraints capabilities, and we're building more and more of those into the enterprise edition of Neo4j. The other reason here that we're saying that Neo4j is very agile is not only can you add and remove your properties, nodes, and relationships on the fly, but the query language is really designed for this. Cypher is the query language that we use. It's a declarative query language similar to SQL, but optimized for graphs. And Neo4j uses it, but there's also more and more companies using it as part of our Open Cypher initiative to open up Cypher as a language. So if you think about, and some people may object to this particular characterization. I've had some comments on YouTube about it, but this is actually a SQL query that was given to us by a real customer. This SQL query is about querying people in an organization and their reporting structure in that organization. And what they do here is actually union a bunch of different queries together. Now, I'm perfectly aware that nowadays in modern versions of SQL, there are sort of recursive operations possible inside SQL, but this is the type of queries that real customers are using in their day-to-day business, either because they created them before those recursive operations were available, or simply because they aren't aware of them and how to use them. But this query, is not only much shorter, it's also just much more logical with Neo4j. So if we look at the Cypher query here, we're trying to find bosses who manage up to 3 levels deep subordinates, and then those subordinates up to 3 levels deep who manage reports. And we're trying to find basically everyone in John Doe's organization and the names of those people in that organization and how many reports they have. And you can see here the Cypher query, first of all, it allows you to do the traversal of the graph into second or third degree relationships. But secondly, you can see that we're using what we like to call ASCII art for graphs. Basically, you can draw out the pattern that you're looking for in the graph and then bind that pattern to a starting point, in this case, looking for a boss whose name is John Doe. So overall, this query language, Cypher, makes it faster for you to write your queries, faster for you to debug your queries, and it's code that's easier to read, so it's much easier to onboard new people, and that's really important for many folks who use Neo4j. Now, I don't want you guys to just consider this a sales pitch here. You can actually look on Twitter. We actually have a Twitter account, Nodes and Rels, Nodes ANDRELS, and that Twitter account has favorited and retweeted. We haven't done this in a while, but favorited and retweeted a lot of amazing comments from people about how much easier Cypher is for them to work with than their traditional databases. So that was a lot in my intro before I gave you my intro. My name is Ryan Boyd. Here's a little bit about my background. I previously worked in higher education, building essentially business applications, enterprise applications, financial applications, admission systems, things like that. Then I worked at Google for 8 years on our Google Apps and Cloud Platform. You notice I still say R, but I've been at Neo now for about 2.5 years, so it's time that I stop referring to Google as R. But anyway, I work with a lot of different technologies on a regular basis. So if you have any questions, feel free to ask the chat inside the GoToWebinar, and we'll have the Q&A period at the end. But you can also reach out to me on email at ryan@neo4j.com or Twitter at RyGuyRG. And I'll try to answer as many questions as I can. So use cases. We've gone through the properties of Neo4j, and we've talked about how those properties make Neo4j a way to query transactional data in a more intuitive way, in a faster way, in an agile way. What types of use cases is this good for? Well, I'm going to go through some of these, but honestly, really comes down to every single type of use case that you can possibly imagine. For a while, we had a goal internally to highlight our top 5 use cases on our website, but then it became 7 of the top 5 use cases, and we're probably up to 9 of the top 5 use cases nowadays. So there's a lot of different use cases that Neo4j becomes handy for because of those properties we talked about earlier. And it really starts with the idea of graphs were used originally for social networks. They were used like by Facebook, used by Google for things like page crawling the web and doing search of the web, and being able to show the ranking of pages based off of how those pages were interrelated. And then other social networks are born, like LinkedIn, and now LinkedIn China actually uses Neo4j for their applications. But it's not really just about social networks. Let's get into some of these. So real-time recommendations. Real-time recommendations is useful for retailers. I think 6 of the top 10 retailers in the world use Neo4j. And this is really about how do we recommend products for people to purchase. So the very simple way of doing recommendations is to basically look at what the person has previously bought and what the person has viewed and what other people have bought, and build a graph out like this. But the best real-time recommendations come from systems that take into account all of those other systems of engagement, as we talked about. So taking into account the logistics systems to understand when will these products be able to be delivered, take into account the help desk ticket systems or the customer support systems. So for instance, maybe you have someone that is shopping for a blender, and the KitchenAid blender is the top blender, and you'd ordinarily recommend that blender to them, but you look back at their history with your support department or your customer service department, and you notice that this user has complained about KitchenAid products repeatedly in the past. Well, you're going to want to recommend a different blender for them. And you're going to look at your logistics system and say, hey, this person's likely shopping for an upcoming holiday. Let's make sure that the blender we recommend can be delivered in time for that holiday. And all sorts of other different systems. So recommendations can be built on top of a lot of different types of data. I'd encourage you all to check out the Neo4j sandbox if you haven't already. I think Corey can type in the URL for that into the chat at neo4j.com/sandbox. And the Neo4j sandbox has an amazing recommendations sandbox built by my colleague Will. And it allows you to spin up an instance of Neo4j and look at the different ways that you might want to perform recommendations on a sample data set. And it guides you through in a step-by-step tutorial how to do recommendations on top of Neo4j. So that's a fantastic resource for you folks. As I mentioned, 6 of the top 10 retailers use Neo4j, Walmart being one of them. And then we have master data management. Now, master data management to me personally is kind of an overloaded term. It means a lot of different things to different people. But in this form, we're going to refer to it as the relationship between employees and customers and suppliers and things, sales channels and things like that. And we have a lot of folks using Neo4j for that. I did want to say, sorry, one other thing with the real-time recommendations. We talked here about retail and product recommendations, but Neo4j is actually used by leading newspapers for recommending content on their websites. And content recommendations is actually how Neo4j was born as well. So it doesn't necessarily just need to be products. It could be content. It could be financial services. It could be all sorts of different things that you want to build recommendation engines for. Sorry, back to master data management. Cisco is one of our top customers there and use us for master data management to understand the relationships between customers and support cases and various solutions that they have available in order to really improve their customer satisfaction when they write into their help desk. Fraud detection is a popular use case. You wouldn't actually tell that by looking at our case studies page, because a lot of the folks that do fraud detection from some of the leading banks and governments and other things don't really want to talk about how they've implemented their fraud detection solution. But we do have some folks talking about it at the upcoming Graph Connect conference, which is at the end of October 23rd and 24th in New York City. Register at graphconnect.com. We have some great folks talking about doing fraud detection there, as well as a lot of these other use cases. But this is really about looking at the relationship between all of these different entities and seeing, hey, maybe we have two different people that end up using the same social security number that live at the same address, but then maybe a third person uses that social security number and lives at a different address. What is going on here? Is there a risk that there is actual fraud here? And so this is how it's used sort of in the world of credit card processors and in the world of financial institutions giving loans and that sort of things. But it's also used for fraud in online gaming, or looking at fraud in money transactions. So the ICIJ, or the International Consortium of Investigative Journalists, used it to look at fraud across a wide network of people opening up offshore accounts, and they won the Pulitzer Prize for that. So graph databases offer new methods of uncovering fraud rings and other sophisticated scams with a high level of accuracy and are capable of stopping fraudulent advanced fraud scenarios in real time. All right, so graph-based search. This can actually be similar to recommendations in the content recommendations that we talked about, but basically looking how everything interrelates. So NASA uses us to build out knowledge graphs and search those knowledge graphs, which has actually enabled them to save, I think, $1 million and at least a year in the journey to Mars, because they've been able to discover problems that have happened in the past operations and avoid them in the future operations. And Lufthansa uses us for digital asset management. That's a graph-based search. Network and IT operations. This is really a great use case for Neo4j, because networks are graphs, graphs are networks, doing root cause analysis, dependency analysis. I won't go into this too much detail because you guys know about this probably as being many developers, but this is a great thing to use Neo4j for and can be used in any company. And there's also some great open source projects out there that use Neo4j. The MacGyver project uses Neo4j, and it's available on GitHub to do this sort of analysis of root cause and dependencies amongst a microservices architecture. And then we also have top networking companies in the world that do that as well. Identity and access management, how everyone interrelates. Typically this is stored in LDAP infrastructure, and I know from my past work in the enterprise, many people actually have dotted line relationships to multiple different organizations, or at a university, people are students and people are staff. And what we did was just create multiple accounts for them. That doesn't really make sense. The user has one identity. You want them to be able to use that one identity across the different assets in the organization. So you don't want a strict tree-like hierarchy. You really want a graph of how that user relates. And this is also used by some of the leading companies doing Active Directory auditing. Another session is going to be on in Graph Connect by the folks at Microsoft about how to do Active Directory auditing of permissions and such with Neo4j, and we also have some external red team consultants that are talking about this as well. All right, that was a lot. So we obviously are used across many different use cases, but also across many different verticals. We don't focus on just a single vertical. You can see a huge list here, and I'm going to move on. So I talked about use cases, and now I'm going to show you a little bit about, and I'm going to go pretty quickly through this, a little about what a SQL developer deals with. And my apologies, I hired this young gentleman to do the handwriting in the upcoming slides. I promise I did not write such horrible handwriting, it was him. A day in the life of a relational database developer. So typical relational database stores data in tables, might look something like this. Name, country, hair color, university, and then you normalize your data and break it out to eliminate duplication and keep things consistent. So you put the countries in a separate table, and then you can put additional information in this other table, such as the leader of the various countries, and as you can see, some of these are very outdated at this point. And then you can reference that foreign key in your primary table here. And you do the same thing for the names of the universities, and you reference that. And this creates your normalized data model in a SQL database. And this shows how all the different pieces of data interrelate on these foreign key and primary key relationships. And this is similar to what you saw earlier with sort of the employee and office data. And when you do queries on this, with 3 tables, you're only doing a handful of index lookups, but most applications or most developers deal with applications that have like 15, 20, 30 different tables that they're joining together, and that's where it becomes very difficult. But this is for an example here, and this basically causes your developers to think about these joins all day long and all night long, and in the end makes them very sad. And so that's actually one of the reasons that we created Cypher, to have a language that's much more understandable when querying across many diverse data sets. Because the data is really a graph, not really a bunch of tables. And so, you know, we do things in SQL databases like use indexes to make our performance faster. And the next step, though, is really, if we're trying to get even faster performance, we have to understand that those index lookups are kind of slow if you're doing plenty of them. So a lot of people end up denormalizing their data, and they're back kind of with the original data structure. And this eliminates a lot of the consistency benefits that they get and such. Of course, there are ways to do this with views, materialized views and things like that in a SQL database, but it just really gets painful to maintain this structure. And so it ends up being fairly complex in SQL to model and store these many relationships because you have an increasing number of index lookups. If you have your data properly normalized, your performance degrades as you increase the amount of data. Queries end up getting long and complex, and that makes maintenance pretty painful. So alternatively, our graph games, as we call it, we think that Neo4j makes it fairly easy to store and model your relationships. Your performance traversal of relationship traversal remains constant with growth in data size. So this is that native graph database advantage that we talked about, the idea that you can traverse from one node to another node in the graph without doing any additional index lookups. The queries are pretty easy to read. and you have that agility that you can add and remove additional properties and relationships on the fly. So this is a quote here from John Resig, who, for those of you in the know, created jQuery, which aside from Google Analytics is probably the most popular JavaScript library on the internet. And he said, really digging Neo4j, what used to be a bunch of complicated analysis scripts are now a handful of simple Cypher queries. So what does this graph look like? If you're taking this data that were in these tables drawn by my young friend there, how would this look like in Neo4j with Cypher? So we're going to talk about Anne loving Dan, and I think I inversed it in this property graph here. In this case, we have Dan loving Anne. So you can see the directional relationship here. You have these two nodes and the relationship loves in between these two nodes. And this is the create statement for it. This creates a node called person with a property with a string value Dan. And Dan loves a person with the name of Anne. That creates that relationship in that one direction. Neo4j is directional. When you create your relationships, you need to create them in a particular direction, but then you can query them without regards to direction. So similarly, if we were to map the tables we saw earlier in this model, we have a person who lives in a country which is located in a state. That person went to a university that is led by a particular leader. And this is how easy it is to read your models that you create. You really should be basically using nouns for your nodes, verbs for your relationships, and you have properties, which are sort of your adjectives on your nodes, and you have properties on your relationships, which are verbs. So here's kind of what that query would look like in Cypher, matching a person who went to a university. That person lives in a country, and that university is led by a leader, and the university is located in a state. And then we do one index lookup here to say, find me the states with the abbreviation Connecticut. And then we do that index-free adjacency as you traverse the rest of this graph. So this is a quote from David Meza, who's the chief knowledge architect at NASA, who's the gentleman that built the tool that saved $1 million in a year going to Mars. He said, I love Neo4j because I can explore relationships faster than you can say SQL join. David is a really fantastic guy, and you can read more about the work that they've done in Fast Company. He's located in Houston, though. That is the one challenge with NASA right now. He's unfortunately in a flood zone. So I guess he probably won't be creating some databases in the near future, but well, you know, give your well wishes to everyone in Houston suffering from the floods there. So how do you use Neo4j? First of all, you create your model, and then you load data into that model, and then you query that data. So in terms of querying the data, Neo4j has a thing called the Neo4j browser that is distributed along with it. The browser allows you as developers to navigate your data in a graphical form, enter your Cypher queries, see the results, export the results, and it's a really wonderful tool to navigate data. Again, you can play around with the Neo4j sandbox to get a hand on how this works. But the Neo4j browser is amazing, but it is intended for developers. So developers typically, or people using Neo4j typically use it by writing code. And we have official language drivers in JavaScript, Java, .NET, and Python. And then there's, of course, many different community-created drivers in Ruby, Haskell, Go, PHP, R, and plenty of other languages. We also do have the concept of user-defined procedures and functions, so you can execute code directly in the database to shave that last millisecond off of your query if you're really looking for that level of performance. There's also an amazing library, of stored functions and procedures called APOC, A-P-O-C, and APOC is available by default on the sandbox. So if you look at the Neo4j sandbox at neo4j.com/sandbox, you can get started today using the recommendations engine or the network and IT data or a variety of other use cases along with the APOC library, which is very popular. This gentleman does not work for a famous employer like NASA, but he has a great quote here. "I can't believe that Neo4j is actually real. Seems like a dream come true." All right, I mentioned earlier that you can use your database alongside, use your Neo4j database alongside your traditional relational database, and you can have your application query both of them. And this is one architecture option that you can do. You can also migrate your data over to Neo4j entirely, or leave it up to developers and synchronize the data between the two. So a typical architecture has an application accessing a Neo4j cluster and potentially also accessing other types of data sources in a polyglot environment. And then you have a data scientist who uses bulk analytic infrastructure or uses Neo4j or uses them combined together. We have a new Neo4j algorithms project out there that we've sought to make high performance graph algorithms for developers using Neo4j that want close to real-time performance for running these types of algorithms like PageRank or clustering and community detection algorithms, things like that. So search for Neo4j graph algorithms. You'll find it in a blog post by Michael Hunger, I believe. But there are a lot of options there for your data scientist to play around with now that your data is in a graph. So like I said, you can basically move all your data, you can migrate a subset of your data, or you can duplicate a subset of your data depending on what types of queries you want to perform. We recognize some data is better formed in a relational database when it's very tabular data. All right, so I'm gonna now skip out of here briefly. And I'm going to give you a couple example Cypher queries here, and then I'm going to hop over to show you something else, a tool that allows you to migrate between a relational database and Neo4j. So the property graph model we saw earlier with the loves relationship. In this case, we have a more business appropriate relationship where Stephen reports to Andrew. But again, you can see we're creating two employee nodes, and we are setting the property on those employee nodes first name to Stephen and Andrew. Now, if you wanted to have a bunch of those relationships and you wanted to query them and find out who people report to, you can simply do this. Find me subordinates who report to an employee. Now you see that thing before the colon in each of the references to employee. That's just an alias. So SUB or E in this case are just aliases which we can then refer to later in our queries to reference those particular nodes. But this will give us all of the people and who they report to, and returns a graph that looks something like this. Now let's be a little bit more specific and return results of who those people report to, and you can return them as tabular results. So Neo4j, for instance, does have a JDBC driver, and you can access Neo4j passing in your Cypher queries over this JDBC driver and work with the results just like you work with the results of any other relational database that has a JDBC driver, because the results are returned in a tabular format, even though your queries and the underlying data model are taking advantage of a native graph format. So if you want to find who a specific person reports to, you can find a subordinate who reports to an employee, where the subordinate's first name is Robert. So you can see there how we aliased the employee there to SUB, and then we referenced that SUB alias in our where query. And that P equals is basically returning us the complete path of that relationship, which includes the two nodes and the relationship itself. Now let's say you want to look at a reporting chain infinitely levels deep. You can do that as well with that asterisk here in the reports to relationship. So in this case, we're trying to find the path where a subordinate reports to an employee. The subordinate's name is Robert, and we want all of the reporting relationships that exist in the data. So that would give us something like this. Robert reports to Stephen, and then Stephen reports to Andrew. And who's the big boss? So basically, find me an employee where it's an empty set, where the employee does not report to anyone, and that is our big boss, who is Andrew. Let me give you this one other example, and then I'll go into that demo and then take a few minutes of questions. So this one other example is product cross-selling, so finding chocolat, basically find all orders that include chocolat, and find the employees and what other products that they included in those orders which contain chocolat. So like cross-selling, how many employees cross-sold other products and what were those other products? And you can see the patterns that we're drawing at the top, make it pretty simple to understand what this query is actually doing. And that gives us something like this. Here we have an employee who sold this product along with chocolat 14 times, Noki, as an example. All right, so let me hop over here. I do want to show you folks the Neo4j ETL components. This is still somewhat new, but you can see that we have 451 commits thus far. And the Neo4j ETL components, you can download it. It's an open source project on GitHub. And basically what it allows you to do here is create a mapping file of how your data maps between a SQL database and a graph database, and it auto-detects its ideas on that mapping by looking at the primary keys and foreign key relationships, and then it generates a Neo4j database for you. So if I show you here that we do have a web UI for it too. This runs locally on your machine. So when you call it, it generates this mapping.json file, which I've selected here. Let me hit reload here. I think I hit the back button at some point, so that probably wasn't the best. But my mapping.json, and I'm uploading the data here to this local application. And basically it says, hey, here are all of the different bits of data in the Northwind database that are specified. We have products, employees, orders, customer demographics, etc. And we're saying what we want to implement or import as nodes and what we want to import as relationships, which is sort of auto-discovered, like I said, based off of the foreign keys and primary keys. And then you can see here are all the different relationships that are going to be in our database. So we have a product is in a category, an order is sold by an employee, an order has a shipper, an order has a customer. Obviously these relationship names can be improved. Those are harder to auto-detect, but you can actually see it will actually show you what the graph is that it will create based off of that data. So what we did here was just connect to the data in their relational database, created this mapping file, and then automatically it created this whole mapping for us. And we can then use this mapping to import the data into Neo4j. Basically, it creates a raw data file in Neo4j that then can be used in the Neo4j browser. And we are out of time. We technically have 1 minute left, but there should be time for Q&A. I just wanted to remind you of this quote from Volcker, and that's really what Neo4j is about. It's about being intuitive by having less code that you have to write. It's about being performant, thousands of times faster in this case, and it's about that agility that you have to adapt your applications like a startup-esque company like eBay would need to have. All right, thank you everyone.